Public television, one of the more important providers of news and entertainment in our lives. So how can we monitor that? Let's talk about a use case where we monitor one of the top TV broadcasters in Germany. Let's welcome CEO of Intellitrend, Wolfgang Alper.
Hello and very welcome. My name is Wolfgang Alper from Intellitrend GmbH, and today I would like to share with you the talk Zabbix meets television, clever use of Zabbix features. This talk is about the second German television, or Zweites Deutsches Fernsehen, and it showcases some examples that we selected for you, which I hope you will find useful or interesting in your next project. The ZDF was established in 1961 as a non-profit television broadcaster by the federal states here in Germany. And 2 years later, in 1963, it went on air officially and already reached more than half of the German television viewers. Later on, the ZDF extended their offerings using the internet by providing live streams and video on-demand service that still exists today, and it's called ZDF Mediathek. Great service, by the way. And since February 2013, the ZDF is also broadcasting around the clock, which they didn't do before. And also as of today, the ZDF is one of the largest broadcasters here, or public broadcasters here in Europe. And they're also present on platforms like YouTube, Facebook, etc. So now we, as promised, let's get technical and have a look into the example that we provided for you. Also, I would like to say a special thank you to Mr. Grunert and the team from the ZDF for the great cooperation in the past. So our first example is how do we get states from an external monitoring system. And what I mean by that is this external monitoring system is not monitoring like storage systems or servers. It's actually monitoring things like power generators, transmission stations, and so on. So something we, as an IT company, usually do not touch. Yeah? And the idea was to pass over the states of those services monitored by this external system, pass them over to Zabbix. So we can see the states in Zabbix as well. So we have Zabbix as some sort of, I would say, umbrella monitoring. So it covers this. And the challenge here was that the services that are monitored by this external system have, of course, states and severities, and the severities are not static, so they vary on what is being monitored. And the question was, how can we do something in Zabbix to deal with the different priorities given for each of those external services? And the approach was, from our end, that we use some sort of low-level discovery. So we have an API on the external system. We can use that to get our discovery data. So we use a low-level discovery to actually discover the services. And then we have another check to do the status collection, or collection of the states of those external systems. And then we need some smart trigger definitions within Zabbix to ensure that we have a proper mapping of severities from the external system to our Zabbix system. So that was basically the idea. And you see here on the slide, on the bottom, you see some very simplified graph which give you the idea about the setup. So we have a discovery endpoint, we have a metrics endpoint, and the external system provides the required data through those endpoints. So the low-level discovery process returned some JSON that you see on the left-hand side, and we get some properties like name, display name, etc., description. But we also get the priority settings for each of the servers and the assignment to the severities we would like to use in Zabbix. So, for example, if the external system would like to pass over the priority severity high, then it would send a 1 as a state. And if the status of the external service is, for example, 2, then this would match the priority disaster in Zabbix. That was the idea. And these assignments can differ from service to service. And you see also the example for the generator. So generator primary returns a current status of 0, which means there's no issue. And the generator secondary returns a state of 1. And if you look to the low-level discovery response, then 1 equals actually to priority high. So that's basically the idea. If the low-level discovery returned by the external system would return something like -1 for a given priority, that is an indicator for us that this priority is not used at all. So here we see the item prototypes and the item prototype definitions. We have just 2 item prototypes, one to get the state and the other one to get the message assigned to a state. And here are the definitions. You see some JSON paths which we need to extract the information out of our LLD response, and also the assignment for the low-level discovery macro names. And these are then used to create those specific definitions. And here are the prototypes, the trigger prototypes. As you can see, we have for each possible severity, we have one trigger prototype, and the check is very simple. We just take what we get from this external service later on and compare it with the constants defined for the service for the given severity. And the result looks like this one here on the slide. So we have, in the upper part, we have our metrics. Basically, that is the message and the status property. And on the lower part, we have an example for some triggers actually in a problem state. And you can see that the severities are really different. So we have a trigger firing in information state, while there's another trigger firing with the average state or priority. This works, and it works okay, but we can do better. And I think you already grasped it. There is an issue in this definition. And the issue is that the issue is that we commonly create unnecessary triggers for individual services, and it's outlined on the graphs that you can see on the slide. So, for example, take the upper one. We have a total of 5 trigger definitions created out of our low-level discovery rules, but only 2 of them are used. The other one are checked for -1, which we know will never be the case. So effectively we created 5 trigger definitions, but we just need 2 trigger definitions. And the question is, how can we solve this? And there's a mechanism in Zabbix which is called low-level discovery override, and that is exactly what we need to solve this issue. So in our low-level discovery override, you see we have 5 definitions. So for each of the given priorities, we have a separate override. And if you look to the override filter and to the override condition, we see we just filter for -1. So if the LLD response contains for a given severity -1, then we select in the condition, please do not create a trigger for this response. And the final result then looks much cleaner. So we've just our 2 trigger definitions instead of those 5. So this is, from my perspective, a good example of using low-level discoveries and low-level discovery overrides, and to really simplify item definitions and trigger definitions and make them more straightforward. Now go to the next example, which is application monitoring. We have using Greylog and using the Greylog REST API. So for those of you who are not familiar with Greylog, Greylog is a log management tool, and in our scenario here, Greylog is not used for alerting, but just for log collection. And we have an application which is called Swings, and this application has 3 components. So we have a web component, an app component, and a gateway component. And what we'd like to do is we would like to collect the data from the Greylog log management system for the Swings application, and to work with this data in Zabbix. So that's basically the goal and the idea here. And because there's an outdated Greylog application used on site, we had to use some external check to work around this and solve the certification issues that we faced. And other than that, the idea was to actually create 3 master items. So for each application, 1 master item. You remember there was an app component, a web component, and a gateway component. So for each of those components, we would like to have 1 master item. And then we, do our HTTP API GET requests to the Greylog API to get data for this particular application. Yeah, and the rest is to, use Zabbix JavaScript preprocessing, low-level discovery routes, etc. to, at the end of the day, create a user-friendly dashboard that people really love working with. So this is the design we're using. So we have our external check, which is getting the Greylog stream, and we call the item here Swings app raw. Remember, because we have 3 components, we need to set up this entire flow for each of the components. So this slide shows just the example for the app component. So our external check grabs the data. Then we have a dependent item which does the analysis of all of the data using preprocessing, of course. And we call this item now Swings app raw filtered. And this item then is used as a master item for at least more than 1 component. So you see that our dependent, also our discovery item, is using this dependent item as a base. And also you see that the item prototypes in turn then create dependent items for each error type. And these error types use also the same dependent item from our first check for further data. So effectively that means that we have just 1 API call to the Greylog REST API created by our Swings app raw item on the left hand side. And then our dependent item in the middle does the heavy lifting, does the analysis and the preparation for the data in a way that can work later on with that more easily. And then we have our discovery item, which based on 2 different prototypes would then create an error count, so the total number of errors by error type, and also a list item so we can see all the log lines in detail. So that's the idea. And this is how it looks like. So we have our 3 master items for each application, and you see the command line for the shell script to execute the REST API call. And when the Greylog application will be updated, then we can move over to HTTP items in Zabbix, which will work fine. And this one shows the simplified JSON output from the unsorted error messages that we get via the REST API. And you can see these are a little bit hard to work with. They look pretty much like log lines only. So we really need some processing here to get good data for Zabbix out of it. And this is done in our analyze item. So this is a dependent item that relates to the previous item, which does the data collection for each of the components. And the preprocessing steps will cover the analysis of the incoming error messages. They will also look for the error types found within the error messages, and then will sort the data in a way that we can work with more easily in Zabbix later on. And the preprocessing steps involved are actually 2. So we have our JSON parse preprocessor to select the message from the Greylog response, and we have a JavaScript item which does the heavy lifting. And this is how the JavaScript function looks like. So we have some regex built in, and we have some data preparation and sorting and so on. And in the last line you see that we are returning then the object again as a JSON object, so we can work with this object later using the JSON preprocessing steps in Zabbix for our dependent items. And here we see the result. So the data stream has been sorted and arranged by error types, which you can see on the left-hand side. And all the detailed logged messages are now children of those error type objects. So for example, session is invalid in handler, it's the first one, and you can see on the right-hand side there are 6 or 7 log lines assigned to this issue, actually, to this error type, which is great, which is what we're looking for. Here you see the dependent item definitions for all of the components, and how we create the error type messages and how we sort the raw data. Again, there's some JavaScript processing involved to solve this. And here's the result. We have our Sphinx application monitoring dashboard. Everyone loves dashboards, at least I do. And we see on the left-hand side the graphs, so the error count by application or by component. Remember, the web component, the gateway component, and also the front-end component. And attached to the graph on the right-hand side, we see some details which are in fact the log lines. And because this is so hard to read, this slide should give you a better idea. So you can immediately see the details, the log lines attached, and if you hover over the graph, you see also the details for each of the components type. So that was the Sphinx application monitoring using REST API from Graylog, using some Zabbix JavaScript preprocessing and so forth. And now go over to the last one. And this is something different. So I would like to share with you monitoring something different. And what we are monitoring effectively here are TV broadcast tracks. I mean, this talk is about a TV broadcast station, so we should talk also about TV broadcast tracks. And here the requirement is to actually monitor those TV broadcast tracks. And as you can imagine, there are different technology inside, very different technology, and would like to monitor what we can, but especially we are interested in the communication between the broadcast van and the transmitting station. And we are interested in the availability and also in the quality of the communication. I mean, the broadcast van at the end of the day needs to broadcast something to the transmitting station. And the challenge was that we only want to monitor a broadcast truck when this broadcast truck is being in use. And to better understand this, it could be that such a truck is going into operation spontaneously, which means that the monitoring team is not notified about that. So what we would like to do is we just want to monitor such a truck when it's used, and we don't want to monitor it when it's not in use. And the approach to actually do this was that we treat each broadcast track as a host in Zabbix that we can put into maintenance, and this way we can stop monitoring. For that to work, we need a what we call a truck control host as an entity in Zabbix, and this truck control host then is driven by some middleware which evaluates the state of the broadcast trucks and some other conditions, and then effectively switches on/off monitoring. And this will be more visible in this slide here, where you see our truck control host, and the truck control host then works with our middleware, which is driven by the Zabbix API, and then we can turn on/off each of the broadcast trucks. And when such a truck is in service and when it starts transmitting data, it will also transmit the duration for how long it will be in service. And we treat this information to then decide with our middleware when we want to shut down the monitoring for a given truck. And this slide here shows more the Zabbix side of things. So we have on the left-hand side, we have our trigger definitions. For each truck is one definition controlled by our truck control host. And then these actions initiated by the truck control host will drive the middleware that either disables maintenance and enables monitoring for a truck, or does the opposite, which is it enables maintenance and turns off monitoring for a truck. Yeah, and as with the slide before, everyone loves a dashboard. So here the final result. You can see trucks being in maintenance, you can see trucks having an issue, and you can see that trucks are in use and don't have any issues at all. So that's it for now. I hope you enjoyed the examples. I hope you found it interesting and useful for you, and maybe we see ourselves the next time. Thank you.
Thank you, Wolfgang, for covering the use case. It's great seeing Zabbix used in different environments and different use cases. As for the questions, feel free to use the chat to ask the questions there, and Wolfgang will gladly respond. Or you can visit the Intellitrend sponsor room for a more intimate environment and ask questions there one-on-one with Intellitrend, and maybe hear about different use cases there also. Thank you.